Hey everybody, let's give this problem a try. So we're trying to find the moments of inertia of a shape that looks like a composite of rectangles and quarter circles. So I just grabbed these right out of the appendix, and it looks like a rectangle, a quarter circle with another quarter circle cut out, and then another rectangle over here. And then there's symmetry. And we're meant to find the moments of inertia about coordinate axes going through the centroid. But I don't know where that is. So let's pick somewhere more convenient, like another set of axes. So for example, we can pick x over here, or maybe like over here, or even down here. Let's go with that one. So let's say x is over here, and I'll use the same y-axis over here. And then afterwards, we can move it to, let's call this x prime and y prime. These are the same. Okay, so let's find the moments of inertia about this xy axis first. Okay, so ix about this one is for this rectangle about over here, it's just 1/12 base height cubed. So let me just write 1/12 base height cubed. Okay, so for this rectangle, base is 3 inches, height 8. These are all inches. Okay, but I need to get it from here to here, so I have to use the parallel axis theorem, plus extra. How much extra? The area of this rectangle, 24 square inches, times this distance squared, 4 squared. Okay, and note that there are 2 of these. So there are 2 of them. Over here. Okay, there are 2 of those. Alright, now let's go for this rectangle right here. About this axis is 1/12 base height cubed. 1/12 base height cubed. The base is, how far is that? Okay, so here to here is 5. Here to here is 2. So here to here has got to be 3. So here to here has got to be 6. And then the height is, let's see, oh here, 3. Right, 3, so 3. Okay. So that's the moment of inertia about here, but we need it to be here. So plus extra, the area of this shape, 6 times 3, times this distance squared. Okay, so how far is that? That's here to here is 8. Plus another 2, plus another 1.5. Okay, I'll just write down what I just said. Okay, so that squared. So this is for this rectangle. There's only one of them, so that's it. Okay, now let's go for this quarter circle, and then we'll handle the cutout afterwards. Okay, so for this quarter circle here, about this axis is right here. So plus pi over 16 minus 4 over 9 pi r to the 4th. So the radius is 5. Okay, so that is here, but we need the parallel axis theorem here. So I have to move how far? Here to here is 8. Here to here is 4r over 3 pi. So, plus the area of a quarter circle, 1/4 of, let me move where I have more space. Hold on. Okay, 1/4 of pi r squared times this distance, which was 8 plus 4r over 3 pi. I got that from here. So that distance squared. Okay. And that is for this quarter circle, which there are 2 of them. There are 2 of these. Okay. All right. And then now this quarter circle cutout. So that's going to be minus, and already I know that there's 2 of them, so I'll just put the 2 already right here. Okay, so for the quarter circle cutout, about over here is right here, pi over 16 minus 4 over 9 pi times the radius to the 4th, and then parallel axis theorem here. So how far is that? Well, first plus the area, a quarter of pi r squared times this distance squared. And how far is that? 8 plus 4r over 3 pi. 4r over 3 pi. Okay, so just punch all this in the calculator. And then that is Ix, about this axis. Okay, so now let's solve for Iy about this axis. Let me make some space over here. Okay, so Iy. All right, so let's start with this rectangle here. And already I know that there's 2 of them, so I'll just start off with there are 2 of them. So about that axis is right here, 1/12 height base cubed, 1/12 height base cubed, the height is 8, base is 3, plus, we have to do parallel axis theorem, the area of that shape, 24, times that distance, 5 plus 1.5, squared. Okay, so that's for this rectangle. Now, about this rectangle, there's only 1 of them. So about this axis is right here, 1/12 height base cubed. The height is 3, base is 6. Okay, so that's that. Now this quarter circle, I know that there are 2 of them, so 2. Okay, so that quarter circle about its own centroid is right here, pi over 16 minus 4 over 9 pi times r to the 4th, 5 to the 4th, plus parallel axis theorem, the area of that shape, which is a quarter circle, 1/4 pi r squared, times the distance from here to here. So how far is that? 5 plus 4r over 3 pi. 4r over 3 pi. That distance squared. Okay, now the quarter circle cutout would be negative, and there are 2 of them. I'll put the 2 already. Okay, so for the quarter circle, about its own y-axis going through the centroid is right here. Pi over 16 minus 4 over 9 pi times r to the 4th, 2 to the 4th, plus parallel axis theorem from here to here. So the area, which is a quarter circle, 1/4 of pi r squared times this distance, which is actually, now that I look, let's rewind a little bit. When I did this quarter circle here, here to here is 3 plus 4r over 3 pi. So I made a mistake right here. That's not 5. This should be 3. Did I make that same mistake earlier? 8 plus 4r over 3 pi. Okay, that was okay. But over here, in the x direction, here to here is only 3. 3 plus 4r over 3 pi, and then over here, 3 plus 4r over 3 pi squared. Okay, so this will be iy about this y-axis, which is the same as this y-axis. So this is exactly the same. Okay, but then for the moment of inertia about this axis compared to this, that's definitely different. About this axis is going to be less than this one. How much less? However far this is, the y component of the centroid. So the answer is going to be ix prime is ix minus something, the total area of all of this, times this distance squared. Okay, so that's parallel axis theorem. Now the question is, how far is this? So let's do that right now. Let me make some space here. Okay. Oop. Okay, let's find the location of the centroid with respect to this this x-axis. Okay, so the y component of the centroid, it's an area weighted mean position. Okay, so where's the centroid of this? 4 inches times this area, which is 24. Okay, and then there are 2 of them. There are 2 of them. Okay, plus, where's the centroid of this? Here to here is 8, plus 2 is 10, plus another 1.5, 11.5, times this area. So that's 6 times 3. Okay. Now this quarter circle, there are 2 of them. So where's the centroid of the quarter circle? It is 8 plus 4r over 3 pi, 4r over 3 pi, times the area of the quarter circle, 1/4 pi r squared. Okay, and then the quarter circle cutout would be negative. I'll just write the area as negative. So plus, there are 2 of them. And where is this? It's 8 plus 4r over 3 pi times the area of the cutout, which that is what's negative, to be precise about it. So this area is what's negative. So that is 1/4 of a circle, pi r squared. Okay, and then just divide by the total area. this, the two of these rectangles, the two, well, let's not forget this rectangle over here, the two of these quarter circles, and the two quarter circle cutouts. Minus. Okay. Okay, so then this is the y component of the centroid. The x component is at 0, right? It's just symmetry right here. And as I said earlier, right, I x prime is I x minus the total area, which is actually this denominator. And then the distance from here to here squared. And then I y prime is the same as I y. Okay, so hopefully this is helpful. So you can just punch this all in the calculator, right? Punch these in the calculator. And then that's the method. Okay, hopefully that's helpful. Keep on practicing. See you on the next video.